Hello, everyone. Thank you for joining. We'll just give a minute here to allow everyone to get settled and signed on, and then we will jump right in. Okay, it looks like we have a good group. I know some people are still joining, but we'll go ahead and get started. Hello, everybody. My name is Crystal Shaughnessy. I am the event specialist at EDB, and I will be your host today for our webinar. I am joined by Vibhor Kumar. Vibhor is the Vice President of Performance Engineering at EDB, and he will be presenting our webinar today on JSON and Postgres. Before we get started, I'll just quickly review a couple of housekeeping items. Firstly, please note the presentation is being recorded, and we will be sharing both the recording as well as the slides after the close of the broadcast. So just keep an eye out for that email. And secondly, please note the lines are currently muted. We do expect the presentation to last most of our time today, but we will be taking questions at the end. So please be sure to put those in the Q&A panel. I will do my best to kind of mitigate questions that are coming in via the chat, but we'll of course give priority to those in the Q&A box. So that being said, I will hand it off to Vibhor to kick us off.
All right, thank you, Crystal. Hello, everyone. So today's topic is JSON and Postgres patted together, right? So what we are going to cover in this session? Well, in this webinar, we are going to cover, first, of course, going to introduce the EDB. If you don't know, you will get to know about EDB, what do we do, and how we help our customers, right? And what is our contribution to the community. Then we'll discuss about the JSON, which is like a document store in the Postgres. We'll discuss about the Hstore, which is again a very old data type which we have in Postgres and has supported many flexible data structures in the Postgres. Then we'll discuss about the history of a JSON in Postgres. We'll go through some JSON data type, the operators and functions which you could use in Postgres. And then again, since we have two different variants of JSON in the Postgres, one is called JSON data type itself and the JSONB, which is more like a binary JSON. We'll discuss about exactly when you would like to use which one. Then there's one example, how would you use the JSONB data type in the Node.js? Let's say if you're writing one program in Node.js, right, how would you use it? We can discuss a little bit about the performance of the Postgres, the benchmark which we did in the past, and then we'll share some important resources with you, right? So this is a kind of agenda of this webinar. So let's start with EDB, right? Who we are and what we do. So EDB is actually a company we believe in accelerating the open source transformation. We help our customers and the prospects, the people who are really looking for adopting the open source technology. They're thinking about replacing their existing databases with the open source database, especially PostgreSQL, right? And what we do and who we are for. We really help business leaders who really think that data is a strategic key component in the environment or for the business. We help our technologies who are really looking for the most versatile technology in the environment. They want to use it for developing a new application, for growing, or of course, to innovate their whole platform using the Postgres. And the managers who really want to free up some budgets, right, and want to adopt the open source, want to start this open source momentum in their life, in their business. With this, there are some important facts about EDB. We have 75% of Fortune 500 Postgres customers who have strategically adopted Postgres for their data. We have 30% of the Postgres code contributed by the EDB, right? This is kind of a source of innovation which we have done. It's a source of innovation for EDB too. This is the way we actually develop the new feature capabilities in the Postgres. We first contribute to the community, and then accordingly we provide it to our customers and the users. We have 1,400 plus global customers, right, who are really using the Postgres in their production environment, and you really deployed a Postgres behind the scenes of the critical applications. We have more than 300 dedicated Postgres engineers working with the community, adding more code, more capabilities, features. 3 out of 7 Postgres core team members are with EDB, right? So we have a central source of community influencers and expertise within the company. When we talk about the Postgres and of course accelerating the growth of the database technology or innovation, then we know that how we can actually help Postgres and how we can really close the gap which people have, and for the adoption of the Postgres. And for that, we know that what enterprise grade DBMS capabilities are, right? What people want, why enterprises would like to adopt Postgres. We actually power their app by adding those capabilities and helping them to use Postgres behind the scene. We also give them a choice that they can deploy Postgres anywhere. So there's a flexibility of deployment choice. Again, this is a kind of a requirement which is there, right? And those who really want to accelerate the innovation, they also want to look for the how they can actually go fast with development of the application. And again, when you're developing an application, you would like to think about a database where you're going to keep the data, right? So I'll pause here and let's see, there is a poll going on. I would like to understand how people are really using the Postgres, or what are the cloud service providers they're using. And we'll wait for few seconds.
Okay, I'll give you 2 seconds and then we'll close that out.
Okay, let's see.
Excellent.
All right, so this is very interesting results. So I can see most of the people are using AWS, where they are really using Postgres. Then second number is Azure, which is of course obvious. GCP is also a cloud platform which people are using for Postgres, IBM Cloud, and there are people say talking about others, right? So it's a very interesting. This is pretty much clear that people are really using Postgres in the cloud, and that's what the flexible deployment choice is, right? Most of the enterprises are looking for the flexible deployment choices, whether they want to, if you want to run Postgres in the public cloud, private cloud, or on-prem, they want those choices, right, to make, and they want Postgres to be available in those cloud providers. All right. So when we talk about the enterprise-grade DBMS capabilities, right, and of course powering the enterprise apps, we talk about the extreme high availability, right? And we, EDB, really help customers to define those high availability around Postgres. We help defining the performance scalability options, right? Again, performance is a key where it varies from application to application. Whatever is your performance need, EDB can help you in that direction. EDB has developed and added many capabilities around the security in the Postgres, which can help you to deploy Postgres in a highly secure fashion and can help you to secure your data while you're storing the data in the Postgres, right? And if you want to migrate your legacy application from the legacy databases to the Postgres, which is more modern, you can do that. And we could help you in that direction. When we talk about the flexible deployment, it means you want to deploy the Postgres, you have the ability to deploy Postgres anywhere. Whether you go with the hybrid platform, most like if you are using the public cloud or on-prem cloud, or if you want to go with the multiple public cloud, like if you want to run some of the application in AWS, some of your application in Azure, we do have options for that. And of course, when we talk about risk mitigation, you want to go as fast as you can without any issues or without any downtime. We have the experts who can really help you, and we can define the best practices so that you can go fast with the best practices of the deployment of Postgres and using it in the application. All right, so with this slide, we started a one poll, and I'm waiting for the result now. I hope people have. All right, this is also interesting information. So the question was that which Postgres service do you use? As per the poll, most of the people are using the AWS RDS. There are people who are using Aurora Postgres. Okay, that's interesting. And they are good customers. So there's some people who are using Big Animal, which is again a one DBaaS solution or Postgres as a service from EDB. There are people using Azure Flexible Server, which is 1%. and 4% of people are using Cloud SQL, Google Cloud SQL. This is very interesting. I mean, again, it shows that you can use Postgres anywhere. Again, a deployment choices which you have, right? So if you're developing application, you have multiple options of deploying Postgres, whether it's a public cloud, private cloud, or hybrid strategy which you're following in your company, right? So let's talk about flexible data types. Postgres already have flexible data types. There are actually 3 different data types. Hstore, which is a key value pair. It is very simple and easy to use. It was introduced in version 8.2. Again, it's a kind of a NoSQL data type which we had added. It's mostly a flat data type or flat data structure, right? Where you can just put the key and value with a comma separated information, right? So that's a Hstore data type. It's kind of an extension of the Postgres. Then later on, we added a new data type called JSON, which is a hierarchical document model. In this, you can actually include a key value pair, plus you can also use object store. You can actually create a nested data structures and you can store into the JSON. And then there is another variant of a JSON called JSONB, which is mainly a binary version of a JSON, right? It is way faster than JSON because when you store a JSON data into JSONB, it actually decomposes the whole JSON structure and store into binary format on a disk. And with this, it also gives you multiple operators. And with the operator, there's indexing capabilities which you can use to faster access those JSON documents stored into the Postgres. And this version, the JSONB, was introduced in 9.4. Again, the first word JSON came into the Postgres. It was in version 9.2, which was just only a kind of a JSON validation on a text data type. And then JSONB is more advanced version of a JSON data type. Now, when we talk about the key value store, Hstore was one solution which was introduced first in Postgres, right? And it was introduced in 2006. It is kind of a contrib module in the Postgres. It allows you to store the data in a key value format in a single column, right? It's like a schema-like structure which you can find with the Hstore. It is fully ACID compliant, and you can actually store multiple values, but in a simple straight structure format in the JSON. It allows you to add a table, and it also gives you some way of extracting a specific component of your structure or data from the Hstore. Again, it's a very flexible and allows you to use into it also allows you to use into a transaction. So it covers your transactional properties, which is ACID compliance. And here is an example of how you can use Hstore in the Postgres. Again, if you want to use Hstore, first you have to again install this extension of the contrib module using a create extension command. After that, you will get one Hstore data type, and you can create a table called Hstore data by giving the column name and the data type. And if you want to store a data, it's very straightforward. You can use insert semantic. In this insert, you can use a values. You can see data is a column which has a Hstore data type. And the way you're storing the data is more like a key value pair. It doesn't support any nested structure of the key value pair in Hstore. So Hstore is purely a plain structured key value pair data which you can store in the Postgres database. Again, you can see it's a key value pair, so you can add as many as keys and values when you're storing a data into the Hstore data type. Right? If you want to access the data, you can simply use select statement. Okay, you can see that in this slide. The next data type which we support called document store. Again, this document store is again JSON. JSON got a lot of popularity because of data interchange capability we have. And again, it's a very lightweight in nature. So that's why because of web popularity, JSON also got a lot of popularity. It was derived from the ECMA script. Again, a programming language, which was a European Computer Manufacturer Association programming language, which focused on around the web. Then after that, as the JSON got popularity, and there's a programming language which got popularity called JavaScript. JSON again got in more use by the developers because they were using this format of the structure for sharing the data across multiple applications or transferring a specific information from one place to another place in this JSON structure because it's more human readable and it's very light in nature. And Postgres got this JSON structure in version 9.2. And with this version 9.2, we also got extra capability called JSON parser capability, which was again with JSON parser and the JSON functions in version 9.3, advanced capability we added in the 9.3. And later on, we added the capability more capability around JSON, this is called JSONB. Because initial version of a data type JSON was only storing the information in a text format, right? And you have to use a specific functions to extract those information. So we thought through, and later on, Postgres actually added JSONB, which is a binary representation of a JSON structure in the Postgres. And with this capability of JSONB, we started adding more and more operators, functions, indexes, so that people can use or store and extract information more efficiently from Postgres. All right, so there was a poll. Poll was around, have you ever tried JSONB in Postgres? 46% people said yes, they have used it, and 54% said no. So those who are not familiar with the JSONB, through this session, you will know that how easily you can store your document data in the Postgres in the JSONB format, and the efficiency of extracting this information using it in your application through this webinar. So this is one example how you can create a table using a JSONB data type, right? Again, it's a one single column, data column, and this is one simple JSON structure which you can see where you have a name, type, brand, and availability of a specific phone, and you can simply use an insert command to store this JSON structure into this JSON data type called JSONB. Very straightforward and easy to use. And if you want to read this JSON structure, which is stored inside the Postgres database, you can simply use select statement. Select query, select data from JSON data, and immediately you will get whatever you stored in the database using this JSONB data type, right? As you can see from the previous two examples, right? JSON is pretty much very well integrated with the ANSYS SQL in Postgres, right? So all the SQL capability which we have in the Postgres, or if you're familiar with the SQL, you can use that capability or that skills with the JSON in the Postgres, right? Whether you the process, the way you want to modify a specific query or tune a query, you can implement same knowledge and skill sets with the JSON too, right? The same language uses the same planner, ACID compliant transition framework can be used with the JSON structure in the Postgres. JSON, again, Hstore allows you to store this object, all these JSON objects which you have inside the Postgres easily. And you can easily modify and use it, right? So you can see how very well it's integrated based on the previous examples. This is one more example. Here you can see the ANSYS SQL and the JSON structure you can use together into one SQL statement, right? So again, it's a one simple select statement where you can use select and distinct clause. You can call the column name called product type, which is again one normal column in the Postgres. And the data is your JSONB data type, right? And if you want to extract a specific value, like a brand value, out of the JSON structure, you can do that. And again, this is more like a JSON structure, and we have an ANSYS SQL like from, join, on, and where. And the JSON capability in the Postgres gives you some operators which you can use to really combine this flexible structure or unstructured data with the structured data. Column data or the rows data, right? And again, to understand this JSONB capability or to learn more about this JSONB capability, you don't have to learn something new, right? You're already familiar with the SQL, and you can use your existing SQL knowledge to interact and store or extract the information of the JSON of the Postgres. This is Again, remember one is the JSON capability in the Postgres is really bridging the gap between the SQL and JSON, right? So whatever skill sets you have, you can use that existing skill sets. Here's one more example, right? You have one simple table called products. In product tables, it's a simple table structure as a structure table, which has the ID column of the integer data type and product name of the text data type, right? And as you know, that products is another one. And if you want to, products another table, right? But if your application is really interacting with the database and understand only a JSON structure, you can call a function called row to JSON, which can convert the structured data into a JSON structure. And this way, your application will be happy and you can interact with the database with a JSON structure. So Postgres allows you to use your existing structured data into JSON format if this is what you want to use in your application, or you can store a data directly in the JSONB format or JSON format, and you can extract and use in the application. And it also gives you ability to really combine or join these two unstructured and structured information in the Postgres using different operators and SQL semantics. When we talk about JSON data types, Postgres supports all the data types defined as per the RFC 7159. If you look at the JSON data types as per the RFC, there are actually 6 different data types. One is called number, right? Which is more like it can contain any fractional part. It can also keep exponential notations, right? It doesn't really distinguish between the integer and floating point. That's as per the RFC 7159. When we talk about a string in a JSON, it's more like a sequence of characters. Any kind of a character, you can store it. JSON structure also allows you to store Boolean data type, true and false values, not really in the format of a string structure, but Boolean format, right? It allows you to store an array, any multiple array or any format of the arrays. It allows you to store any object, which is more like a nested JSON, like JSON and another JSON structure. You can use that, and you should be able to segregate the key and the value using a colon format, right? And JSON data types as per the RFC also allows you to store null. All these data types are supported in the JSON format or the JSON data types which we have in Postgres, right? This is one simple example. It shows you exactly how the JSON data will look like in Postgres, right? And this is the way you can store it inside the Postgres. Let's talk about the history and a little bit more timeline around the capabilities. This actually gives you an idea exactly how we have matured this JSON capability in the Postgres. Again, as I mentioned that it was introduced in version 9.2. From 9.4 version, we got JSONB capability, which is a binary representation of a JSON. And with this, we also added some extra indexing capability. It's mainly to how fast you can search a specific data, how fast you can access your JSON stored inside the database. With the 9.5, we added some extra functions, or I would say operators, which could allow you to actually access this data or manipulate this data within the database itself before really you pass the data from a database to the application. One of them is called JSONB set. JSONB pretty is more mainly about prettying the representation of a JSON stored inside the database. If you want to convert a specific a string structured JSON into JSONB, you can use two JSONB command function. These are JSONB object, which is mainly for validation and verification or adding of the JSONB structure inside the JSON document stored in the Postgres. You can really create a one JSONB array using a JSONB build array function. If you want to create an aggregation, or if you want to aggregate all those JSONs stored inside the database, you can use a JSONB aggregate function. In the same fashion, if you want to concatenate, or if you want to combine two different JSON documents, we have a concatenated operator, which is two pipe sign. And if you want to strip specific nulls, which are there inside your JSON document, you can use JSONB strip nulls. So you can see like this, we have added some more functions and capabilities inside the 9.5. In 9.6, we added a JSONB insert capability, which allows you to actually insert more JSON documents into your existing JSON structure stored or data stored inside the database. With PG10, we get text support for JSONB, which allows you to store a specific string if you have indexed it very well, or all the text capability which you want is there now part of the JSONB. 11 version allows people to use PL Python with the JSONB. Again, if you are very familiar with the Python language, which is considered as a modern language, and you want to use that Python capable skills, if the Postgres, you can use that with PL Python. Then in version 12, we added the JSONPath. JSONPath function allows you to search for specific object, specific key inside the JSON document stored in Postgres. It allows you a more structured format, right? So if you're already familiar with the path or how you would like to use JSONPath, you can use this function and use the same structure as it is to extract information from the JSON. JSONPath also allows you to use data time. This is another capability which we added in the version 13. In version 14, we added the subscripting language, subscripting capability with the JSONB. So you can use actually subscripting with the JSONB to extract a specific information from JSON. Again, this was a pretty much very useful for developers who are really familiar with the array structures, how to extract a specific information from the array or data, right? And this actually gives you that ability to use it in the application. With this, there is a more capabilities added, but again, remember JSONB with all these extra capability, with all this, the transformation happened over the period, right? It still maintains the transitional context. You can still use it in the transitional context, right? It's fully ACID compliant. It has indexes like a GIN, B-tree, just trigram hash, which you can use it to access information quickly and in a fast manner, right? With this, we have a lot of functions and operators with the JSONB, which you can use in an application to extract specific information, which you could also use to manipulate the data in the Postgres. JSONPath, if you have used your JSON in your JavaScript and you're familiar with the path, JSONPath, you can use the same semantics with a JSONPath function to extract information, right? And again, we have done a benchmark, and this is just only we are going to discuss maybe later in the slide, but just want to give you that the JSONB capability which we have gives you a good performance way better than MongoDB if you have used in the past. So here is one example of a JSON where you can see there is a structured JSON, or I would say nested JSONs used in one bigger JSON, right? JSON data. In the first JSON, you can see there is a JSON structure. It's more like an object storage or object format of the JSON. And there's an array of a JSON, which is again part of this bigger JSON. You can store this whole format as it is in the Postgres. This is one more example where you can see you can use a flexible address specification. Again, address is another key, and in this key, you can store a one JSON. And if you want to use an array, simply array notation or array capabilities also available in the JSON structure of the Postgres. And this is pretty much supported in the JSONB data type. And if you want to use a JSONPath, you can simply use a JSONPath query. And if you're familiar with the JSONPath, so like in the JSONPath, it always starts with the $. And if you want to look for specific keys, those keys can be used with the $sign, right? And if you want to, whatever the value you find, it is a value of if the value is a text format, you can use a text operator called @ with your query, right? So this is one example you can see, which actually checks whether the last name particular exists into a specific path of a JSON structure or not, and the value is equals to of arc or not, right? And immediately you will get a result whether the specific in this is another example where you can see that what we are doing, we are actually extracting the phone number, right, from the user's data. And in this user's data, what we are doing, we want to extract the phone number of the JSON structure or JSON data which we have, which has the last name equals to Smith, right? It's a normal notation, you can see that it starts with the dollar searching for the last name. In the last name, it's looking for in the last name data, it's looking for a Smith string, right? And if this particular class gives you a true result, the value will be shown to you on the screen, right? And here's a one result. So Smith has these two fonts, and this is more like an array structure stored inside the JSONB. If you want to use this JSONB with a Node.js, right, using it with the Node.js is very straightforward. We have a connector called PG, which you can use it, and you can download it directly from the Node.js site. You can simply use a connection string. Here you can see PG is the one connector which we have used it, and you can pass the username password with the host in the connection string. After doing that, you can use, of course, create a one connection handler. In the connection handler, you can execute the queries, whichever you want to use. So in this simple example, you can see that what we are doing, we are simply creating a one table first, and then if the table does not exist, it will be created. And first we are truncating the table in case there is any data inside it. And then later on, what we are doing is storing the JSON data in this specific table, right? Let's say if after storing the data, you want to query that particular table, you can do that easily using a select star from EMPs. And you can print this whole JSON structure as it is through this particular Node.js program, right? And if you want to iterate over the data, you can use a for loop. So you can see it's one simple example which shows that how you can use Node.js with the JSONB of the Postgres. Okay. Now, people may be thinking about it, okay. So before we move on, right, to JSON or JSONB, there's a poll question. Again, the database technology which you can use. The question is, for unstructured data or flexible schema, which database technology do you use, right? There are many options there. Let's wait for the response.
Sure, let's give them like 5 more seconds and then we'll close it out.
All right. Great.
Okay, and there are your results.
All right, that's very encouraging. So a lot of people are really using Postgres with JSON. Some people are using MongoDB. I can understand that part. Some people are also using the Amazon DynamoDB, which is like 9%, and 18% are using other. I'm not sure what others technologies are there, but these are the known technologies, right? Now, as you know that, coming back to our webinar, right? As you know that Postgres supports 2 different JSON data types, JSON itself and JSONB. The question comes when to use which one, right? So in this case, if you, first of all, Hstore is a one more data type. If you have a simple plain structure for key and value, you can use Hstore or you can use JSON, right? But when you talk about making a decision between the JSON and JSONB, if you have a specific need of a JSON, then you need to keep in mind that JSON is just only a validation of a structure before storing into a text data type inside the Postgres, right? So this is more like a data type which actually validates the JSON without processing and store it as it is inside the database, right? And store it as a text data type. It maintains the all key and the value structure or the structure as it is, whatever the form in which you are inserting the data, right? It also preserves the duplicate values. Like if you have a JSON structure where you have a duplicate key, it will keep it as it is inside the database. And again, it maximizes just only for storing the data and extracting the whole JSON document as it is, right? But if you want to look for a specific key and a value, right? Or you want to search for a specific data inside the JSON document, right? Then JSON may not be a right solution for you, right? You would like to go with a JSONB, which is more feature rich, which has more operators. And it, again, the way it stores the data allows you to access specific component out of your JSON data. So with this, we actually did a one benchmark. Again, this benchmark was done by the third party OnGres. we coordinated with them for performing a benchmark because we wanted to be a neutral. We wanted a neutral third party to really look at the PostgreSQL and MongoDB and do a current benchmark. So this was a benchmark. It was done in the 2019 and published in 2019. In this benchmark, we used the PostgreSQL 11 and MongoDB 4.0. The company name is OnGres. We did this benchmark on AWS using the EC2 instances, and the detailed finding is already there. So here's the result. We found that when we did this benchmark with PostgreSQL 11 and MongoDB 4.0, we actually use a JSONB, and MongoDB use a JSON data type for storing a JSON document, right? We found that PostgreSQL was better than MongoDB in terms of performance. It's more like 4 to 15 times faster than MongoDB. This is the complex transaction which we had performed using a document store, in which we included a JSON document, modify the document, specific data element, and store it, right? Then after that, we also did one more benchmark using a sysbench utility, right? And we found that MongoDB was faster initially because a lot of connections were coming to the PostgreSQL. But when we added a connection pooler with the PostgreSQL, we found that PostgreSQL with the connection pooler, if you have a lot of connections coming to the PostgreSQL database, right? PostgreSQL with the connection pooler is way faster than MongoDB. That's a very interesting, encouraging result, which shows that the JSONB is in the PostgreSQL is highly optimized and gives you ability to store a data which you can extract quite fast, in a fast manner, right? Or in a quick way. With this, we also actually moved from the minimum many small transactions to large data sets, and we thought to try out exactly how it's going to perform with PostgreSQL. But you can see that with sysbench, when we stored a huge data sets in the PostgreSQL and MongoDB, PostgreSQL really outperformed with a connection pooler. Again, we always recommend people to use connection pooler if you have so many connections coming to a database. And with this benchmark, which clearly indicates that JSONB plus PostgreSQL plus PG Bouncer, which is a connection pooler, is an optimal solution for storing a JSON document and extracting it. And again, this is we did with the 2 terabyte of a data stored in the PostgreSQL. Right? So overall, you can think about this way. Postgres gives you ultimate flexibility. If we talk about modern application using a Node.js, if we talk about a flexible data type, Postgres has that for you. So whether you want to develop your application and some portion of a code inside the database using a PLPG SQL or PSQL, TCL, Perl, Python, any language, you can do that with Postgres. If you want to store structured data, you can use PostgreSQL. Whether you want to deploy the Postgres in on-prem, want to go to the cloud, or if you want to go into the microservices, or if you want to go with a private cloud, you can use Postgres everywhere. And if you are really thinking about the modern application or using a Web 2.0, 3.0, again, a very modern application you want to develop, you can do that. If we talk about unstructured data, we have multiple options available for you. Based on your use case, you can use JSON or JSONB. JSONB is, again, allows you to store any amount of data and fast access through Postgres. And we have multiple cloud deployment options. EDB gives you options. You can use Postgres anywhere, right? We also have one DBaaS solution called Big Animal, which you can use it, which allows you to create a Postgres service in Azure and AWS. And you can use this flexible structure or unstructured data, flexible structured data type with the structured data to create your modern app, which allows you to really work with both kind of a data in the Postgres. That's why we say, right, instead of saying no to SQL, say yes to the SQL, right? For Postgres, it's not only SQL. We allow the users to store structured data and structured data both. That's why we have a different data types available for you. You can use any kind of a workload with a Postgres, as you have seen with the benchmark which we did with a 2 terabyte of data, and Postgres gives you the ability to store the data of a huge JSONB structure and can extract in a proper way without losing your ACID properties from the application. So do more with the Postgres and see enterprise NoSQL solution, which is structured and unstructured both for Postgres, right? There is some more blog post, which again, this is information which I want to share with everyone. Michael Stonebreaker, who's the father of Postgres, has actually written some blogs around the MongoDB and the unstructured data, right? And remember, when you are working with the unstructured data, you have to think about how you can extract or convert this unstructured data into structured data before using it, right? So you need some kind of a transformation layer for converting or extracting this information from the unstructured storage, right? So that's why you can think about Postgres allows you or gives you both the capability. You can store unstructured data, and later on, if you want to do some analysis, work with unstructured data and make some meaning out of that, you would like to think about structure. And for that also, Postgres gives you the functions, operators, which you could use to convert unstructured into a structure. So these are some useful resources. This will be very, very useful for you when you're working with Postgres and JSONB structure. Again, here, these links will give you some information around how you can perform, update, insert, delete with the JSON structure, how you would like to build a JSON document, how you can use relational tables with a JSON document. So I've included these important resources, which we will be sharing with you after the webinar. And with this, I'm open for the questions.
Yes, excellent. Thank you, Vibhor. We covered a lot and we have kind of reached the end of the presentation. So if there's anyone who has any outstanding questions, please just take a minute to enter those into the Q&A panel. And we do have a couple to start off with. The first question that came in, is it possible to have double non-numbers in JSONB?
Double non-numbers, no. Not in the JSONB, it's not supported. I think we are still working on it.
Excellent. Okay. And the next, in terms of space usage, does JSONB use less space than JSON?
Not really. So if you look at the JSONB, it actually decomposes the whole JSON's data into a key and value, and it's stored into binary format. So decomposition, when you decompose the whole data so that again, there's a reason why we decompose it, because this way you can access this information quickly, right? And it also allows you to use different indexes to access information. So, so when you decompose it, of course, it's going to take more space than the normal JSON data type.
Okay, great.
Okay.
We have a couple more coming in here. Is it possible to make inner joins using JSON?
Yes, you can do inner joins. Again, you can see that you can use two different JSON data, and you can use join semantic of a SQL. There are some specific operators which you can use it to compare the elements or the key values of two different JSON document. You can do all this stuff easily with the Postgres and JSONB data type.
Great. Let's see. Is there any compromise on performance when querying using JSONPath?
No. If you use a real correct, again, JSONPath, when we introduce, there are some indexes which also support the searching of this specific data from a JSON document, right? So there is no impact. If you have proper indexes on the JSONB document, you can use JSONPath efficiently.
Okay. In the case of spatial data, is it possible to use files in GeoJSON format following the same logic?
I need to check for that. GeoJSON, we do support, like you can use points, you can use all the geospatial data information into the JSON structure. But file format, I'm not sure exactly what you mean by that, but maybe we can take it later. I can take it offline.
Okay. Should we use JSON to store records that we need to be constantly updated?
Well, with the JSON, I won't recommend that right now because again, people are working on this. If you are constantly updating, right, I would like to recommend you to use normal structure format in the Postgres, right? You would like to use JSONB if you're, I mean, it allows you to update a JSON document inside the Postgres. But if you're, I mean, again, if you're updating JSONB often, right? Often means like every 2 and 3 seconds or 4 and 5 seconds, then I would recommend you to go with a normal structured table in the Postgres.
Okay. Is compression on the roadmap for JSONB?
Yes, it is in our roadmap, and we also working on that, so it'll be available for you.
Okay, great. And we have one more. If I have a if I have a table using is it Hstore? History?
Hstore.
Hstore. If I converted that to JSONB, would my query performance improve?
Yes, it would. So it's a very interesting thing that JSON Hstore out of the box allows you to store the key value thing, right? Key value pair data. But when you convert into JSONB, I think the indexes, the optimization around the operators, right? All those actually made it to access this data more quickly and in a fast way.
Okay. And we have one last. How is Hstore different from JSONB?
So again, Hstore doesn't allow you to store nested JSON structure, right? And it doesn't allow you to do a nested array structure, JSONB data at all. So Hstore is more like a plain single structure in which you can include key and value. That's it, right? But if you want to store complex data, like if you want to store person name, telephone number, multiple telephone numbers, which will be again array, right? Or if you want to store address in that format, in the address, of course, there will be a street, there will be a pin zip code, right? All those information. So you can see it's more like a complex structure. So complex structure is not possible in the Hstore. And I think JSONB again meets all the requirement of modern data or whatever you want to achieve with Hstore. You can get that with JSONB. So if you're using Hstore, I would recommend you to try JSONB or migrate over to JSONB because JSONB gives you more capabilities, more operators, indexes, which actually allows you to access information fast from Postgres. Okay.
Excellent. Might have one more here. Does append to JSONB slow down significantly with the size of the existing JSONB blob?
Again, I'm not sure about the append. When you talk about appending a JSONB, is it the same JSONB which you have inside the database? If it is, right, then I don't think that will be much. I think it's not going to slow down the performance. It's just only because you are just appending it, adding the information, storing into a database, right? But even if you have just want to mention that there is also one limitation which a size limitation we have for JSONB, that's 1 gigabyte. Anything which is beyond 1 gigabyte, we don't ask people to do that. Use anything within the 1 gigabyte. Again, 1 gigabyte is a very big size, right?
Okay. We have a lot of good questions. Is ORM defined as the ability to handle complex or nested JSON structures?
I'm not sure which ORM you're planning to use it, but if you are thinking about Node.js, then yes, you can use it. The connect actually allows you to map the JSON structure which we store with your JavaScript very easily and quickly, and you can actually interact. It's like you can interact with the data coming from a database on Postgres in more native way with the JavaScript.
Okay. Excellent. All right. Well, that was our last question. Of course, you'll receive an email follow-up from us. So if you think of anything else, you're more than welcome to reach out to our team. But thank you again to you, Vibhor, for such a great presentation, and to everyone who joined us for this webinar. Please, like I said, keep an eye out for the email. You'll receive both the slides and the recording in there. And I hope everyone has a great rest of the day.
Thank you, everyone.
Bye-bye.